So start off with an easy one just to get our morale picked up. And this is non-calculator, isn't it? Yeah. Okay, so this is what they were given last year. They were given an exchange rate, and that's why I looked at it just to check it wasn't calculated then, because that seems like a pretty nasty question. We're told that £1 to $1.52. So I'm timesing that by 1.52 here and dividing that by 1.52 here. Gareth exchanges £300 into US dollars. How many US dollars does he receive? Well, 300 times 1.52 is the easiest thing in the world to do. But if you go about this in the right way, it's going to be quite easy. If I times it by 100, £100 would be equal to $152. Agreed? And then times it by 3. Again, not the easiest in the world. I'm going to set it up like this. Can we see that? Okay. So then 2 times 3 is 6. 3 times 5 is 15, and then 1 times 3 is 3, add the 1 is 4, so $456. All good? Adrienne wants to exchange 585 US dollars into pounds. Estimate how many pounds Adrienne is likely to receive. You must show you're working. Okay, so estimating. I'm going to change that to 600. So I'm going to say what I'm doing though to show that I'm estimating. So you do squiggly equals like that. Okay? And then $1.52. What am I going to change that to? 2. Happy?
1.5.
1.5 will be way more accurate, but they can't argue with you. If you put 2, if you round that to the nearest whole dollar, then it is 2. For me, that's what I would do because it's easier, but I am going to check the mark scheme on that before I say exactly. So we would then do 600, and we divide by to change back, don't we, to get £300. But I wouldn't mind just double checking that one. Do that quickly on here. So past papers, GCSE. Paper 1, aren't we? Paper 2 higher, I want paper 1 higher. There we go. So what are they giving there? Yeah, look, there you go, estimate in a range 360, 410 or 300. Okay, so which one was easier? Probably Karan's way. Okay. However, if you do it your way as well, well, you did as 1.5, it's fine, it will get there. It's just maybe a little bit harder. If I did do it that way, if we did 600 divided by 1.5, I wouldn't like it like that. I'd say times that by 10, but you'd have to times that by 10. So you get 6,000 divided by 15. Then how many 15s goes into 6? It doesn't. Into 60. 4, then add 2 zeros. Okay? So that's like a quick way of dividing by it. So £400 there. So these are 2 different ways. All good? Okay, so I'm going to the back now, okay? 21 is the actual proper back page. Okay, so what are we looking at here? Any idea what we're thinking of just looking at first glance?
Probability.
Probability, very good. In fact, yeah, that's the key word. Anyone want to have a go at talking me through? You don't have to come up. Just tell me what I need to do. Go on, Reese. What are you doing there?
You put probability to even.
Yeah, very good. Okay, so you can only draw 2 options. That's good. Even, odd. Now, if you do this one up here properly, it's going to pay off down here as well. Okay, so just having a quick scan ahead. This one says find the probability that one of the tickets drawn is even and the other one is odd. And then the one beneath says find the probability that at least one of the tickets drawn is odd. Okay, so I can set that properly and I can use the same tree both times. So let's say even, odd, and then even, odd, even and odd again. Okay, so what's the probability I get an even number? 10 out of 20? Certain? There are always sort of numbers that do confuse you. I think, is it definitely 10 out of 20 when you look at it? If you need to, just rattle them off. Go, right, I'll get 2, 4, 6, 8, and just count them through on your hands, okay? So 10 out of 20 in both. You could say a half, but I wouldn't bother, because if I take a raffle ticket, even though, it does say here, not replaced, but they could have got away with not saying that, because it's obvious. If you take out 2 raffle tickets, once you take the first one, it's out there, isn't it? There's the winner. You don't say, oh, let's put them back in and give them another chance to win. Everyone kick off, wouldn't they? Okay? So the chance of me getting an even this time would be 9 out of 19. Yeah? And this one would be 10 out of 19. And this one here would be 10 out of 19. This one here would be 9 out of 19. All good? Okay, where does it do what I want it to do? It says the probability that one of the tickets drawn is even and the other one is odd. So which branches am I interested in? That one and that one. All good? If it said that it is even, then it is odd, then it would only be that one there, the one I've got ticked there. But the fact it says that one of the tickets is even and the other is odd means that it could be both. Agreed? So we'd have 10 out of 20 times 10 out of 19, which is going to give me 100 out of 380. And then we're going to get the same again, aren't we? 10 out of 20 times 10 out of 19, which again is 100 out of 380, which gives a total of... We're good? Except for my funky 8. Happy? Find the probability that at least one of the tickets drawn is odd. Do I need to set up a whole new tree? What's the point? Waste of time. Which opportunities I'm interested in? Bottom 3. Or you could say not the top one. If you say not the top one, you do 1 minus these probabilities times together, or you just basically find this one and add it on to what we just had. I would preference the second way personally. I think it's more intuitive, but some people like to go this way for a shortcut. Okay, so I'm going to work out the probability of odd, so that's what POO stands for, which would be 10 out of 20 times by 9 out of 19, which is 90 out of 380, and then I'm going to do 100 out of 380, add 100 out of 380, plus 90 out of 380, which comes to 290 out of 380. Do I need to cancel that down? No. Does it tell me to? It's a point you might get it wrong. Okay? All good? Okay, back to the front. You probably can't do this one properly on yours because it's been shrunk down. So it says the route from Edinburgh to Dundee is approximately 4 centimetres on the map. Okay, maybe you can do it. The actual journey is approximately 100 kilometres. Complete the scale in the form 1 ... Okay, so we know that 4 centimetres is equal to 100 kilometres. We just need to change that to being 1 centimetre equals how many kilometres? I'd halve this to being 2, so I'd halve that to being 50, and then I'd halve it again if it was me. But you could have just gone straight to divide by 4 and get 25. Okay? Watch out for B, it's not as easy as you think. Calculate the journey, oh no I didn't say that, sorry. The journey from Edinburgh to Dunedin takes 2 hours 30 minutes by car. Calculate the average speed. So as soon as I've seen calculate the average speed, I'm going to draw a triangle. Which got speed is equal to distance divided by time. If you forget which way those go round, think of what the speed limit is on the motorway. What is it again?
70.
70. 70 what?
Oh,
Miles per hour. So miles being a distance divided by per hours being time. So miles per hour. Okay, that's how I always get it if I'm ever thinking, now which way around do they go again? So speed is equal to distance divided by time. So that would be the distance. How many centimetres is it on the map? They told us it's 100 kilometres. So it would be 100 kilometres divided by 2.3? 2.5, very good. Okay, that's 2.5 hours, isn't it? So they're trying to trick you. For me, don't want to do 2.5 into 100. What am I going to do instead? Any ideas? Times by 10. Good. So 1,000 divided by 25. I'm going to use exactly the same trick I used a second ago. How many 25s go into 1? None. Into 10? None. Into 100? 4. How many zeros appear now? 1. So it is 40, we say kilometres per hour. kmph. All good?
So what do you do if they ask for it in like per minute or something? How would you change it?
Per minute, if they did ask that, you need to change the 2 hours into minutes and then add on 30 minutes. So 2 hours would be 120 minutes, add on 30 minutes, 150. So it'd be 100 divided by 150, which would be like 2/3, 0.6 recurring Lewis.
You know, with kmph, there was a slash between the
You don't have to. If you could write it as 40 km/h, like that. In fact, actually, that was probably more widely recognised. Actually, that one. Paul.
Sir, isn't the scale like normally it's like 1 centimeter equals like 1 centimeter in the real world? Or
Ah, I think you're right. Yeah,